Hey, day 5. We are doing awesome. So, day 5 is just really going to be reviewing all of the different rules that we have learned now for all the derivatives. And so you've got them all down, hopefully. So we are going to just practice selecting the different rules. So here, basically, I love this little table. It's just kind of saying, hey, like, what are we doing? So this one, I can see that is telling me I'm going to be using a product rule. So I have a first and a second. So my first was x cubed, and I think that's a cube, yeah. And my second was secant x, okay? So let's see how we do on this next one. Is this a product? No. If it was a product, I would have seen like the cosine of x times the ln of x. This is instead putting this on the inside of the function. So this is a composition, meaning we need to use the chain rule. So then what's the inside going on? And what's the outside going on? So my inside here, this v of x, is the ln of x. And the outside here, the u of x, is cosine of x. But this is going to be the chain rule. So let's look at this one. I want you to think, which rule is it? And again, it's a composition. It is a chain rule. So my inside here, this v of x is radical x, and my outside for u of x is the arctan x. Okay, number 3. This is my quotient rule. So the numerator is sine x, and my denominator here is 1 plus sine x. Okay, number 4, think through this. This is a product rule. The first is e to the x, and the second is the cosecant. Cosecant of x. Okay, number 5. That's that composition. So that's where we're going to be using the derivative of e. Is e exactly like you see it times the derivative of that. Okay, but it wants u is e to the x, and the v part, that inside, is the arcsine of x. Number 6, quotient. So the numerator is 3 to the x, and the denominator is 3 to the x plus x. Number 7, product. The first and the second. Okay, now we're going to go do, actually that's a typo, that's all of them, 1 through 7. Okay? Okay, so number 1, we're going to look at this one. Number 1 was the chain rule. So we're going to take the derivative of the outside, leave the inside alone, times the derivative of the inside. There you go. Okay, number 2. So this is our tan rule. So 1 plus that inside squared times the derivative of that inside. And then we can reduce. I'm going to put the 2 on the bottom, then the x to the 1/2. And then I have 1 plus this guy now, that absolute value of x. Actually, the square's on the outside, so it just becomes x, my bad. And you could leave it like that. Okay, number 3, low, d high, minus high, d low. Draw the line and square below, or all over, low, low. Simplify that. See if you can get it to this. All right, number 4. First, derivative of the second, plus the second times the derivative of the first, and that's just our easy e. And I just factored out an e to the x cosecant x. And I put this one first since that was a minus. To me, that would be the most simplified. Okay, number 5. So arc sine 1 over. And then still that arc sine of x. So that's where we brought over the exact same thing, and then we had to multiply by the derivative of that sine, arc sine of x. Okay, 6. Okay, number 6 goes low, d high, minus high, d low, all over low, low. X plus x. Okay, on this one, I'm going to go ahead and pull out that 3 to the x. And then, so I took that out from both of them, and then I'm going to distribute here. I distributed the 1 as well, but I took that out. So if I look at this, this is kind of nice. Let's see, it looks like these two are exactly the same but opposite, so they go away. All over that denominator. Okay, number 7. So that's our product rule. The first times the derivative of the second plus the second times the derivative of the first. And I'm going to factor out, well, let's reduce that first, x to the negative 2/3 plus the ln of x times 1/3 x to the negative 2/3. So I'm going to go ahead and factor out that x to the negative 2/3. So that would be 1 plus 1/3 times the ln of x. So when I bring that down, I still have that 1/3 I don't like, so I'm going to multiply by 3 over 3. There we go. Sweet. Okay, look through those and tell me which one the chain rule does not apply on. So which one do you not need a chain rule? And you can select more than one on here. So this one I have an inside, I need the chain. This one I don't see, I see just a power, a product, a constant, so no chain. I'm going to select B. And here, I am not, let's see, this would be a power. Look at that. This also is no chain. Let's see here though. Oh, I've got an inside, so that's going to require a chain. So in fact, this one has two answers, B and C. All right, this one looks fun. What's going on here? We got x, f of x, f prime of x in a table. Says that it gives me selected values for a differentiable and increasing function. And I know every time I see this, I'm going to say, therefore, f is continuous. And its derivative. So let g be the increasing function given by this, okay, where g of 3 equals 9. Just like, okay, thank you for that info so far. Oh, look at this. Which of the following describes the correct process for finding g inverse prime of 9? So now we're reviewing, if you remember, the inverses. So the first thing I have to do is say, well, where does g of x equal 9? And we just got that right here to say that's going to be 3. So then the next thing I need to find is g prime of 3. So I'm going to take the derivative of g, and g was up here. So that's f prime of x plus, oh, I've got a chain rule, derivative of the outside, leave the inside alone, times the derivative of the inside. So the g prime of 3 is f prime of 3 plus 2 times f prime of 6 now. And f prime of 3 was 1/3 plus 2 times f prime of 6. 6, f prime was 3/4. So that's 1/3 plus 3/2. That would be 11/6. Probably went too far. Which one did it want? Oh, it just wants me to select what we were doing. See if you can find the correct one here. Well, look at g prime. G prime of 3. This one's right. This one's not. It doesn't have the 2. Neither is this. There's the one with the 2. And oh yeah, that one doesn't have what the rule that we need, so it is A. Okay, one more. Reviewing everything, we're also going to bring in implicit differentiation. Okay, so I want to find the slope of the tangent, so no equation, just the slope. So the first thing I need to do is find this derivative. So this is an arctan. So the derivative of an arctan is going to be 1 plus the inside squared. And then on the top, we're going to have the derivative of that inside. And then that one goes to 0. Now let's go to the other side. So this will become 2x minus 3. Took the derivative of y again, so dy dx. Oh, look, they're trying to tricky. That is just a number. Okay, there's no x's or anything, so that goes to 0, and that still goes to 0. So here's what I have so far for my first derivative. And that's really what it's wanting you to say, is which one are we going to use? And that was C. And I will see you in class.